We are on to Unit 6, which is all about probability distributions. Now, what are probability distributions? Well, they describe how the probabilities of different outcomes are distributed for a random variable. They give a complete picture of the likelihood of all possible values the variable can take. Okay, so this will be similar to Unit 5, but there are differences. We're going to start off today with 6.02, create probability distributions. And here are our goals. Determine whether a distribution represents a probability distribution. Represent a probability distribution of a discrete random variable in graphs and tables, and develop a theoretical probability distribution for a discrete random variable. Some words in there you may not have seen recently, but I think you're going to find this lesson to be quite simple once you get the hang of it. It is very repetitive, and this is really the only new skill. This is an example of what it looks like to create a probability distribution table. What's going to happen, oftentimes, you'll be given a frequency table, and you'll be asked to make a probability distribution table, or maybe just to find one individual probability. Here's how we do it. Looking at the first table, we have number of kilograms and frequency, and we're dealing with bags of corn flour in a grocery store. The way you interpret this table is there are 12 1 kilogram bags of corn flour in the store, and there are 8 2 kilogram bags, and so on. Now, remember how to find probabilities. To find any probability, you need to divide the favorable outcome over the total. Okay, so in order to do that, the first thing you always want to do is add up all of the frequencies to find out just how many of whatever it is there are. In this case, it's corn flour bags, right? Be very, very careful when you're adding those because if you get that wrong, the rest of it will be inaccurate too. Okay, so going down the list, if I wanted to find the probability of finding a 1 kilogram bag at the store, I would take 12 and divide by the total 50 to get 0.24. Then what's the probability of getting a 2 kilogram bag? Take 8, divide by 50, I get 0.16. Notice there also is a correlation. The bigger the number in the frequency, the higher the probability. You can always turn these into percents. And one excellent way to check your work is always to see if all probabilities add up to 1. Because 1 as a percent is 100% of everything we're looking at, right? If you're rounding, sometimes it won't exactly equal 1. You could go back and double check that and maybe add 2 or 3 decimal places if you'd like. But if it's super close, you can feel pretty confident you did it correctly. And that's it. Step 1, find the sum of the frequencies. So add them all together. Step 2, divide each frequency by the total to find your probabilities. And of course, in this table, it says probability instead of frequency, so make sure you label that accordingly. And ultimately, add them all up to see if they equal 1. That is really it. And now it's time to practice. As always, pause to practice and then continue. Here we go. A survey asked a group of people about the size of their households, and the results are in the frequency table below. So there are 4 households with 1 person, 12 with 2, and so on. You get the idea. There's a frequency table, or sorry, probability table below with only 1 probability filled in, and they ultimately want to know the probability that a household size is 2. Now, you could do that without filling in this entire table, but it is good practice, especially since you're just learning this, to fill in the entire table and then answer this question. So if we weren't asked to fill in this entire table, you could just take a look at, okay, where's the household size 2? There it is. So I'm going to take the frequency of 12, divide it by 25 to get 0.48. That would answer that question alone. But they also wanted the entire table, so we take 4 divided by 25. You can see all of that work written out here to find all of these probabilities. And don't forget to always check at the end, if you add these all up, do they equal 1? That is what you want to check and be sure of. So get in the habit of that. Add these all together, see if they equal 1. In a medical study, the heights of a group of men were measured to the nearest inch. So we're not talking about fractional inches, a third of an inch, none of that, just whole inches. There were 120 men with heights of 60 to 64 inches, 280, 65 to 69 inches, 312, 70, 74 inches, and 162 men between the heights of 75 and 79 inches. This time they want us to complete the frequency and the probability distribution table. So one column for frequency, the other for probability. We're solving the same way. The only difference now is the frequency table is not filled in, but they told us what we need to know. So try your best to fill all of this in and then answer this question on the side. Check your work. Ultimately, we're adding and dividing. That's it. Add all of these together. These values, of course, came from the information they gave us, and then divide over here to find each individual probability. Answer is A. Create probability distribution. We're doing the same thing, just with a spinner. And there are 4 possible outcomes. It could land on 1, 2, 3, or 4. But there are 6 sections overall. So take a close look and try to fill in the probability table. We know it's probability because of the letter P, but we weren't given a frequency table, and how are we going to do that without it? Well, they didn't tell us the outcomes, right? Like here, they told us this many men are this height, this many are that height, right? They didn't tell us all the outcomes. We're just looking at the chances of being in groups 1, 2, 3, and 4. Okay? So the way you would solve this is, right, the probability of X, that's that discrete random variable we kept talking about, being 1. 2, 6 simplifies to 1/3 because there are 2 number 1. Same thing with number 2. There are 2 number 2s out of 6. Same probability. 3 and 4, there's only 1 3 and 1 4. So 1 6 for both of those. So the discrete random variable X represents the outcomes of what we would land on spinning this. All right, here we go. Another probability question. And we're getting close to the end, actually. This is a shorter lesson and very repetitive. A game host spins a color wheel 200 times. Man, their arm must be tired. This frequency chart shows the results. Colors, frequency. You're doing the same thing, you're just representing the values using a bar graph this time. So notice all the values on the side. Your bars will go up by however much that probability is. And now let's check our work. You could have added these all up, all the frequencies, but you didn't even have to in this situation because they told us the total was 200. You could, of course, double check this, and you should absolutely be in the habit of adding these. But if they tell you, I'd say it's okay to just put your 200 in your denominators, and then you take the values. Red is 20, 20 over the total. Blue is 10, 10 over the total, and so on. Okay, so you'll notice all those probabilities are seen by where the top of the bar goes to, and you can quickly check that these do make sense. For example, orange, there were, sorry, not orange, let's look at green. There were more green than anything, so green should have the highest bar, and it does. Yellow was second biggest number, so yeah, that should be second highest. And that pattern continues with blue being the shortest. And your exit ticket for today, different, just solved differently than any problem we've done today, but it's not solved in a way you haven't done before, and it's applying one particular thing you learned today. Let's see if you can find the value of n. Let's see how it goes. Well, the key thing to remember here is that all probabilities equal 1. 100% chance of one of these things happening, right? So I add them all up and set them equal to 1, and that's an equation. And you've solved an equation with one variable before, right? Nothing new from this point. Get your common denominator by finding the GCF, right? So we're multiplying this first fraction times 8, the second times 3, this one times 4 to get our common denominators. Of course, the numerators change as well. And now it looks simpler, but we need to isolate that n, so we subtract the fraction. And once again, we need a common denominator. So we have 24 here, while 1, remember, is the same as 1 over 1. And in order to get 24 as a denominator, we would multiply the top and the bottom both by 24. So we can now finally subtract and get our answer that can be simplified to 3/8. And if you got a negative answer here, that should be a red flag because probabilities can't be negative. They have to be between 0 and 1. And that's it for 6.02. I'll see you next time.